Hey everyone, in today's video we're going to start talking about isosceles triangles in geometry. Let's go ahead and let's get started. So, an isosceles triangle, what is it? How is it helpful? When can we use it? So what an isosceles triangle is, it's a triangle that has two sides that are equal. Okay, there's two sides that have the exact same length, and that third side we don't really, it's just a different number. Now, when we have those two sides equal, the other thing that these triangles have in common is that opposite angle from each of those sides. So here we have an example of basically the two important factors, a diagram explaining what are the two key things about isosceles triangles. Well, two sides have to be equal. So here in the top triangle we can see that these two sides are equal to each other. That's one feature of an isosceles triangle. And the other feature that we have is these angles will also be equal to each other. So it's essentially the angles that are opposite of those equal sides. So this side would point to this angle and this side would point to this angle. So those angles will always be equal to each other. And the nice thing is that there's this theorem that essentially tells us that, hey, if you have two equal sides, you know that these two angles are equal. Or vice versa. If we have two angles that are equal to each other, opposite on opposite sides, then we know that these two sides have to equal to each other. Okay, and again, this is all because this is one of the benefits of an isosceles triangle. And the way we use this is a lot of times they'll give us either one of these angles or they'll give us both of these, and we'll have to find out the side lengths based off of them giving us one of them. Okay, so and we use the properties of isosceles triangles to essentially just help us find extra side lengths or extra angles, and that's what we're also going to look at right now. Okay, so let's go ahead and let's take a look at a problem that's pretty typical to find in some sort of geometry class. Okay, so they want to know what's the value of x. They want to know what is that value, and we can tell that this is an isosceles triangle because we have these two sides that are congruent to each other, which means these two sides are equal to each other. Now the theorem that we just saw said, well, if these two sides are equal to each other, then you know that these two interior angles would also be equal to each other. So I know because we have an isosceles triangle that this angle over here that's not labeled would also be 28 degrees. Okay. Why is that important? Because now I can use that information to help me solve for x. Because I know another theorem that says that inside a triangle, all the angles inside a triangle need to add up to one magic number, and that magic number is 180 degrees. And I have all three angles. So I can set this equation up by writing 28 degrees plus another 28 degrees. And then I can add this angle, which is 5x plus 9 degrees. All of that together has to equal 180 degrees. And now it becomes an algebra problem that I need to solve. So adding these two 28s, we get a 56 plus 5x plus 9 equals 180. I can add this 56 and this 9. That would leave me with 56 plus 9 would be 65 plus 5x equals 180. We can subtract the 65 from each side. Zoom out a bit. And we would get 5x equals 115. Then that would just leave me with having to divide by 5 on both sides. And I would be left with x equals 23 degrees. Which is what the question asked me to solve for, so x equals 23. We'll just say 20 degrees. So this is one way to use the isosceles triangles theorems. Okay, again, this was the one thing that made this possible. Okay, I'll say this. is that they told me that these two sides were congruent. I'm not allowed to assume anything in geometry. That's a very big idea and concept. We can't assume things unless it's given to me. So because they told me that these two lines were congruent, I was able to assume that these two angles were equal to each other. I knew, well, not assume, I knew for a fact, okay? Because there's a theorem that says if they have two equal sides, then those two angles are equal to each other. So that's nice. X equals 23. Let's go ahead and let's look at another problem. Again, this problem has to do with finding angles. This one's a little bit more straightforward, whereas again, they tell us that, hey, these two sides are equal. And why does that matter? Well, because there's a theorem that says if those two sides are equal, we know that these two angles have to equal each other. So for this problem, I would just set these two angles equal to each other. I would have negative 4x plus 9 equals 8x minus 3. And now it's just a matter of moving things over. Let's go ahead and let's subtract 8x from both sides. And at the same time, we're going to go ahead and we're going to subtract 9 from each side. Okay, negative 4x minus 8x, that would give me a negative 12x. These 9's would cancel out, which is nice. These 8's cancel out. Negative 3 minus 9, that gets me negative 12. Very nice. I could then divide by, let me actually rewrite this in red so we can differentiate our steps. Negative 12. I can then divide by negative 12 on both sides. And I end up getting x equals 1. And we've solved both of these for x. Pretty nice, pretty easy, pretty straightforward. So that's how we use this theorem to help us find angles. What if they asked me to find an actual side length? Okay, so for this one, this is a two-step problem. This is a pretty nice problem. They want us to find the value of x, and then they want us to use that value of x to help find what each of these side lengths are. So this time, instead of them giving me that two sides are equal, they told me that these two angles are congruent, which allows me to know I can use the isosceles triangle theorem. Okay, because if these two angles are equal, that means this is an isosceles triangle. Because it's an isosceles triangle, I know that these two sides have to be equal to each other. So for part A, finding x is going to be able to, we're going to be able to do that by setting 8x minus 1 equal to 4x plus 5, because that would be setting these two sides equal to each other. So now we can go ahead, let's do some algebra. Subtract 4x from both sides, add 1 to both sides, and we get 4x, these cancel out, equals, these cancel out as well. 5 plus 1 would be 6. So 4x equals 6. I can divide by 4. And I'm going to go ahead and use this as a decimal, because it might make it easier plugging it in. I would get x equals 1.5. So now I know what x equals. Now the second part to this problem would be plugging in x so that I can find what each of these side lengths are. And that's what part B is about. So part B, we can take that 1.5. Now, it doesn't matter which one of these two sides I plug into, because those two sides are equal to each other. So I just need to plug it into one of those sides. Underneath, I'll also need to plug it into this side, because that side is a different measurement. So let's go ahead and let's plug it into 4x plus 5. So we're going to do 4x plus 5, and we're going to plug it into 2x plus 11. So first, plugging it into 4x plus 5, we would get 4 times, again, now what we're doing is we're taking this 1.5 here and we're plugging it in. Plus 5. 4 times 1.5, that would be 6. Plus 5, that would equal 11. So now I just found out that this side actually equals 11. which means this side also has to be 11. Now let's plug it into 2x plus 11. So down here, I'm going to replace that x with 1.5. So I'm going to get 2 times, again, we're taking that 1.5 and we're plugging it in. Plus 11. 2 times 1.5 is 3. Plus 11 would get me 14. So now I know that this side underneath is 14. So hopefully now you know what an isosceles triangle is and how to use some of its properties to help us find some angles and some side lengths. If you feel like you need to go back, rewind, pause, and replay, by all means do that. That's always the best way to learn math. But hopefully eventually you get to a point where you're like, okay, cool, I get this. Now what you want to do once you get to that point is you're going to want to check out these next couple of videos, one of them which is on the perpendicular bisector theorem, okay? And then we're also going to talk about equilateral triangles and about how we use their properties to help us solve certain equations. As always, I just want to thank you. Feel free to like and subscribe so that you get notified when these new videos come out. And I'll see you guys next time.